First of all, my name is Anna. I come from a company in Europe that's called Infinum. We do design and development. We're an agency. We work with a lot of clients. This is the Android team. This is actually the only picture I could find of us, and it's blurry. Most of our pictures are blurry. We're probably a little off here. The team has grown since then. We added a few more colleagues. And in this team, my specialty and my line of work, basically I take care of security for banks. Security in general is a vast topic. We could spend much more than 45 minutes on it. We will try to focus on basic things, many basic things that we can do to improve security in our applications. And throughout the presentation, you'll see that basically adding them up results in a good product. As far as security is concerned, well, banks tend to have different approaches to it. Some focus on prevention, but most banks tend to focus on mitigation. That means that one day when somebody makes a huge withdrawal from your account, they will call you up and ask you, oh, did you pay a certain amount of money to that and that company? And this is great, but it's something that should be an added layer of security, where the first layer should be the one you put in the quality of your application and all the standards that you apply to the build itself. So let's start with the basics, and that would be build integrity. What I mean by build integrity is all the little things you can do when creating a project, creating your super secure application that aren't as complicated, but will have a huge impact later on. So I'm going to be a little obvious here and tell you that you need to add a release key store to your application. As I said, we have a big team, and it often happens that few of us have to work on the same application. And while we're in debug mode, I really hate it when I give my phone to another colleague and tell him to deploy his changes on my phone, and he has to reinstall it because the signatures don't match. So good rule of thumb, which we have begun using, is that when you create a project, you create a release key store immediately, and you sign all your builds with that one. The simple reason is that you will need that release key store for publishing to your Google Play account. And the other reason is that you don't get irritating reinstalls between your team members as you develop. As I said, it can be used for all build types. I suggest you do use it for all build types. And I'm going to be Miss Obvious here and tell you that you really don't want to lose that key store, ever. You learn from experience. So our experience was that a few years ago, we had a colleague that worked on a project from scratch. He developed an application. He finished that application and pushed it to our Google Play account. And a few months later, he left the company. And a few months after that, the client said, oh, we would like an upgrade. Fine, what do you want us to do? They give us the specification, we implement it. And there comes the day that you have to push that update to your Google Play account. And we don't have the key store. So our colleague was super secure and placed the key store outside of the Git repository somewhere else. The problem is that we didn't know where that somewhere else was. So you have to tell your client, whoops, we made a mistake. We cannot publish your application. And that's really bad for you. You don't want to end up looking like an amateur. Thankfully, the laptop that the colleague was using was still in our company, so that problem was averted, but I cannot describe the shame that you feel when you tell the client that you have misplaced the only thing that's needed for another publish or an update of the application. And the other obvious thing that you should keep in mind that it needs to be safe. So if somebody acquires your key store, they hopefully won't have access to your Google Play account, hopefully. But if they do acquire your key store, they can repackage your application, add some malicious code inside, and put it somewhere else, publish it on a different site, and send email to random people, hey, this is a new cool version of Facebook, why don't you download it from this link? And if they signed it with your key store, or Facebook's key store, the users will hopefully not download it, but if they do, they will be able to upgrade the app. So this is a huge issue, and keeping your key store separately stored somewhere, not in your Git repository, is mandatory. So just to take something out of this, I know everybody likes Gandalf, so again with the images. Another thing that I said, you don't keep your release key stores in your Git repository because, again, somebody could technically get to them. And if you have a large team and your team members leave, you don't necessarily want them to have access to it because the whole procedure can occur. Another thing that people do is put key store data directly in their build Gradle files. Just a quick check, is anybody still using Eclipse? That's the reaction I was hoping for, so nobody. Okay, so you don't want to put this data directly in your build Gradle because, again, somebody can get to it. This is just one alternative, and it's an easy, obvious, and not important one, but you can put key value pairs in your local properties or build Gradle properties or somewhere else. You can use system environments, variables and then reference them, or you can use properties and then parse them and use it like that. But the main reason is that you can reference something that doesn't contain the actual data from your key store. So that's one way to mitigate this issue. And another thing that people usually do by default but don't know the implications of it is to enable obfuscation. So you usually obfuscate to minimize the APK, to remove unnecessary resources, to shrink the build, but you also make your code unreadable. And it's crucial because making your code unreadable for you will also make it unreadable for somebody else. So this is, again, from the generated build Gradle file, where you see references to TXT files that basically contain rules for your Proguard rules. So people don't like Proguard. Has anybody here ever had problems with Proguard? Has anybody here hated Proguard ever? Okay, I see one hand, that's enough. People dislike it basically because of the second two reasons. Builds fail because when you add Proguard in the beginning, you develop, you add libraries, but you kind of forget to add rules for those other libraries. And most self-respecting libraries have a little section in their README that say, oh, for Proguard, please add these 2 lines. But people don't do that until they have to release their build. And that's the last bullet here, staging versus production. So you wait until production to try out your build that has Proguard in it. You should add Proguard to all your builds. So whether it's debug, whether it's staging or production, it will cause problems when you try to debug the app, but at least you'll know straight away that you have forgotten to add some kind of rule. So, and again, builds fail, and then you have to go through the libraries that you added and try to find the one that broke the build and add rules for that. So this is basically, I hate it too, but it's because I'm lazy and I always kind of wait until the end. But if you add it as you develop and add other libraries, then you should have very little problems with it. If you don't like Proguard, and I think we've agreed that you don't, you have other options. These are just 2. They're tools that you can add to your builds, and you can basically write rules for your application. So you don't just get minimization and obfuscation, you can also add some build tempering detection, so they're powerful. They have, I think the Dex Protector has kind of a trial period, so you can try it out, but I think they both are commercial solutions. So if you tend to look at obfuscated code, I don't know about you, but it's basically the code you see at first year in college, when you just started programming and you're so super hyped, everything's going to be awesome and short, and I'm just going to use one-letter words for variables, and it's going to be really compact. So yeah, this is kind of the example of that. So it's harder to read, but that's the point behind it. And the final question is that we kind of think that we have managed to secure our APK at this point, but the truth is that you can reverse engineer an Android application very simply. So there are tools, and by the 500,000 results shown here, you can really start with anything. And the problem with that is that your APK is a zip file, basically, so unwrapping it and using some tool to get data out of it is not a big problem. Hence the tampering detection. So when you've obfuscated your file and you've added your key store, you kind of want to check whether somebody has downloaded it, maybe changed it a little, and whether there is something wrong, potentially if it's run on a rooted device or something else. So there are three simple things that you can do with your build, and that's verify signing certificate at runtime. You can place your signature somewhere in the app, preferably throughout several variables so that it's not placed somewhere obvious. You can also verify the installer. So just a few lines of code to check if the installer is Google Play. And another thing to check is whether the app is run on an emulator or if it's debuggable. Again, very simple to do. Another problem we had is at one point in time, we started getting a lot of crash reports for an application, which was weird because the frequency of the reports was very high. And upon inspecting Crashlytics, we found that somebody was running the application on a rooted emulator device. So having some kind of dialog that would raise up when your app is run on an emulator or is debuggable, and telling the user, hey, there's something wrong with this build, please don't use it, or maybe exit the app, would be a much better solution than just allowing your users to do whatever they want with the build. So that's the part of build integrity. And the next part that I want to address is data privacy. So I think that most users are very sensitive about their data. I'm talking pictures, I'm talking conversations with your family, your loved ones. You don't want other people poking and prodding at it. So Android says that there are three basic ways to store and retrieve data. We have internal storage, we have external storage, and you can use content providers for the same thing. Basically, we're asking ourselves if the data is private. So internal storage, in general, is private. It belongs to your app, only it can access it, and it's fine for most things you want to store for your app. The external storage, share preferences are a subpart of the internal storage. Basically, whenever you want to store some kind of user preference, you use share preferences. It's not for big data, so basically just simple information. And it's also stored in the private section of your app. The external storage, as it says by definition, is generally readable and writable. That means that your app can change the data, other apps can change the data, and the user can come and delete whatever kind of configuration, picture, or file you placed in the external storage. So that's not private by definition. And the third thing, content providers, well, they're more of a storage mechanism used for sharing data between applications. One good use for this would be if you have an application that requires you to log in. And logging into that application will also allow you access to some other application. So you don't have two login processes, but one. It's safe, but you have to do a little writing to make it safe. Basically, those two things that are on the screen is all you need to make your content providers secure. They have to be exported for other applications to use them, and the protection level for them has to be set to signature. This means that only an application that's signed with the same key store as your default application can use the content provider. So again, we're kind of referring to the things we've already done with our build. This is an overview of those storage mechanisms. So basically, all we know is that in general, internal storage and by definition shared prefs are private, while the other two options are not, or it depends on how you configure them. But the question is whether it's safe. Generally, yes, until you do something with your device. And that's basically rooting it. Once you root your device, everything you've done to ensure privacy is out the window. You can root your device for malicious reasons, or you just want to remove the bloatware that comes with it. Either way, it's fine, but it's a reality and you cannot influence it. So one solution to it is to encrypt stuff. If you have to store some data on your device from your application, and my strong suggestion is that if you don't do it. So the safest way to keep data on your device is to not keep it at all. But if you have to, encrypt it. Find some library or tool that suits your needs, is usable, and encrypt all the things that you need to have encrypted in your application. So here are just a few of the options. I will not go into them, but as you see, you have options and you don't have to reinvent the wheel. Just use whatever is available. And when you encrypt stuff, you might still want to prompt your user to provide some kind of authentication method, some kind of PIN or password. And that PIN or password should probably be the key that you use for the encryption. Well, short answer, wrong. The long answer is that if you use some kind of PIN to encrypt data, how many options for a 4-digit PIN can you come up with? Louder? 10,000, that's right. So 10,000 options just for cracking the application. So if you have time, I know you all here don't, but if you have time and you're really set on breaking something, you can just go iterate for them and try the basic things, you know, birth date, anniversary date, all the things that people tend to use as passwords still. I personally know by my mother because when she gets her PIN in the mail, she usually safely tucks it away in her wallet and thinks, okay, everything is fine now, nobody can get to it, and nobody can withdraw money from my account. So using some other method like password is a better option, but it depends on its length and complexity. One other thing I wanted to mention here is that when you unlock your phone with your PIN, like I said, you have 10,000 options to try out, but you will try with the obvious ones. And if you use a lock screen, pattern, you have raised the bar for about 40 times. So there are about 389,000 unique, distinct patterns you can create on your device. So that's always a better option than your PIN. But again, human nature is the core of most problems on everything, including security. So most people will start at the top left point and just draw 3-4 items, so that number decreases drastically. If you use some kind of password or something, don't use it directly. You can use something that will transform your PIN or password into something more complex. You can use bcrypt. This is just one of the suggestions, which is basically an algorithm that transforms your PIN into some kind of key that's longer. It iterates through its magic, its function, and it's much harder to crack because the computational power that's needed to crack that kind of password is just unparalleled to the ones that's used for, MD5 and SHA1 or other hash tables that you can get to. So encrypt the data and don't do it directly with the PIN, transform it into something more complex. So my question at the end of this section is, can your data remain private in any way? So no, private definitely not, because rooting your device basically allows access to everything, including the data. But if you don't encrypt data and you keep it on the device, then you're just, asking for trouble. So don't allow misuse of the user's data. And if we take care of our build integrity and try to implement some kind of privacy for the user's data, then the next thing we need to take care of is network security. This is actually, it's a fun thing to do because it's not as complex as people think. So if you want to make things safe, you will use HTTPS. I will just ask for a show of hands if anybody here is using HTTP in their applications. Everybody's on HTTPS? Amazing. Amazing. Very proud now. So as you know, HTTP is a text protocol and the text is just right there. So if you want to compare HTTP to something, it would be like writing your credentials on a postcard and sending it through mail to the ending recipient. Anybody can intercept it, anybody can read it, and of course, anybody can use it. So HTTPS, as you all know, basically encrypts the communication channel, which makes the whole communication between the app and the servers more secure. I say more secure because this is not enough to prevent the man-in-the-middle attack. So if you're really playful, you can use Charles proxy or something else and just place it to intercept data between the app and the servers. So if you give that person your device and he decides to install the Charles proxy certificate on your device, if you use it, you will not get any kind of warning. Your device will think that it's talking to the server, and the server will obviously think that it's talking to your application, regardless of the HTTPS. So the solution for this problem is to pin stuff. So pinning certificates has its merits. We use it frequently because it adds that extra protection layer that is needed in some of the applications we have. And what it does, it defines which certificate authorities are trusted. So without certificate pinning, your application will trust all the certificate authorities that are placed on your device, which is fine. But if your client wants to use a custom certificate, then you have to add it somehow. You can add it on your device, but having to ask 4,000 users to install an additional certificate just so they could use your application without warnings and problems is irritating. Nobody wants to do that. So you basically pin the certificate in the application, so the effectiveness of the tag is reduced and the users can use your application to communicate with the service. This is for an older version of OKHTTP, which we use because who doesn't love Square libraries? And this is basically all that's needed to pin certificates. This is also an example that shows that we pinned two different certificates, client and server, which is not necessary, but pinning the server certificate is a must. So what happens when the certificate changes and you have pinned it? Again, I think you learn from experience. So when you get a call Monday morning from your client saying that the app is broken, nothing works, the world is about to implode, and you ask them what has changed, and they say nothing, everything's the same, we have just upgraded the certificate. And then you ask yourself and the client, okay, do you remember the time when we pinned that certificate in the application? Sure. and they're still drawing a blank. So this is a problem that we generally have with our clients, is that they don't really understand the impact of the implementation has on the release cycle of the app and on the security features on the server. So when you do pin certificates, you need to know how to inform your users and your clients that the change will break everything. So if you do need to change your production certificate, and you have some kind of mechanism like when you log into your application and the server tells you, okay, there's a new version available, please upgrade. This doesn't work because the login call is probably under HTTPS itself, which means that there's no communication at that point. So you want some kind of outside mechanism that can notify users, there's another version of the app available. Please install it due to security reasons or whatever you need to tell them. Or you can use even Google Cloud Messaging or Firebase Messaging to notify them of the change. Another fun thing is the amount of users that don't have auto-update set in their devices. This varies from region to region, and it also varies between users and their age group. Older users tend to not upgrade their apps even if their phones are burning, because that's evil and it's fine, I'm used to the version I had before. But this also poses a problem for you and your development cycle, because users will not be able to use the application. And most users tend to respond, it's not working. So there's no context. There's no way you can help them unless they're informed of the changes that will have to happen. Also, one thing to plan in advance is the impact that server setup has on your devices. So if you go to Quellis site and type in any kind of URL from your website or something else, you get the complete security overview of your site. So if you're in the A or A plus or minus, good job. If you're on lower grades, then you probably need to rethink your security strategy on the server. But where it impacts Android is basically setting the security level on your site will also kill off some of the devices. As you know, TLS 1.0 is obsolete. It's not to be used anymore, but it will also eliminate the 2.37 devices that, believe me, are still used, and clients are reluctant to eliminate them. So good thing to do before you upgrade your security is to look at this site and see what kind of impact it will have on your users. It's context aware, as most things are, so you need to find a compromise between the reach that you want to achieve and the security on the server. Another thing that you can do, and this is the moment where Android has begun producing serious and good things, use the platform to your advantage. Starting from Android M, you have a one-liner that basically breaks all HTTP calls in your app. So simple as that, you can just disable all HTTP calls. So you go through your app, it breaks somewhere, it's not working, no data, good. You forgot to take care of that one call, now's the time to do it. You can also set the strict mode policy, but it's not necessary since you have the parameter up there. Another thing that has got more traction is the biometrics in form of Fingerprint Api. We finally have a standardized unified API for fingerprint storage and reading. And the most important part of it is that it's sufficiently secure now. So Samsung is not trying to do their own thing, HTC is not trying to do their own thing. We have the TEE definition that must be complied with, and it's basically okay now. Another thing in form of security, but also annoying your users. Who here likes the open with dialog you see when you try to click on links in your... Somebody likes it? Okay. Okay, choice is good, I agree, but for the most part, I just hate when I have to perform that extra click to open the link with the app that I want. So starting from M, like I said, you have now the power to configure for a certain domain, a website, what app will open it. So there's a link, a unified link between the app and between the server that will basically launch your app each time a link is launched. So this is the configuration. Basically what you have, just a second, what you have is the place where you need to plant the JSON file with the configuration of the server, and this is basically all the code that's needed to link that to your application. That's what you place there. So another thing is, with the coming of Android M, we have a network security configuration feature, which basically all the stuff we did with certificate pinning, clear text data, and other stuff, you don't need to do in code anymore. So you have one unified file which allows you to set all the security features, exclusions, inclusions that you want working for your app. So first thing you need to do with that is add it to the application tag. And as far as configuration, I tried to bold the things that can be done, just a few of them, so you get the picture. So you can determine whether you want to use clear text or not. You don't. You can define the trust anchors that you want in your app. So again, user certificate, you place it in your app, but you don't need to read it, place the passwords and other stuff that you needed to do before. You just tell that this certificate is the one that's going to be used for the communication. Again, you can use another set of tags for pin set expiration, but it's generally not a good idea, because after it expires, well, you know what's going to happen. So basically, you have a file which you can configure, and it contains all the security information in one place. So yay, Android, finally. And another thing that's obviously important, the clients you're working with. You need to be an authority, and you need to lead by example, which means that it's your job to tell them how to improve the security of the application and the whole process. You have to keep them up to date, which means if they tell you that they plan to upgrade their certificates in 6 months, that's a good thing, because now you have 6 months to notify the users that their apps will stop working. If there are security issues, patches to be applied, it's your job to notify them immediately and try to roll out a new version of the application with those things applied. So things to take away from this presentation is basically, if you need to use storage, use the internal storage, but encrypt the data that you place in it. Use HTTPS, which we all are. Good job again. Certificates, you can pin them. You can now use the configuration file that will hold all the features that you need for your application. And again, be aware of the update cycle, because breaking stuff for your end users is not cool, and basically it damages your ego, and basically it carries a message that you're not doing your job right. To take away, generally and specifically, Android is not secure. I'd say not secure as the iOS platform. I have both phones, and I generally tend to feel more confident with using applications on the iPhone. But what's important in the whole thing is that everything that you do in your application regarding security is just another deterrent for your malicious attacker. So you're not creating a safe application, you're just adding bits and pieces of rules that will make it harder for somebody to break it. It will make it harder for them to change stuff in your build, to intercept data, to read the data, and sniff the communication between the server and the application. So that's one thing to carry out. We can make it better, and we can make it definitely less easy to abuse. So, for the end, I would just like to thank you for your attention today. I will be mingling around. Excuse my drowsiness. I'm still under jet lag and kind of feel like a zombie, so I might provide you with better communication and answers tomorrow when I know my name. I will be providing the slides after the presentation with a few links that you might find interesting regarding security and the things that we do. So thank you very much. I think it's secure enough. It just depends what you need it for. So what do you plan to store? What do you plan to... So it's not relevant. It's not relevant to this presentation in general, as in we're not storing accounts. The idea is not to store anything user-related on the device ever. But as a mechanism for account storing, then it's fine. So it's okay to use. So the question was whether we need to, whether we can set up some kind of certificate for the use of the application or monitoring of the data. We tend to use Charles and heavily because it's the easiest way. We don't actually use it to intercept data for the tampering issues, but we use it because one of the main problems we have is API. So when we work with external clients and you get your specification for an API, it's never the way they send it. So we need to see what's coming in order to build the app. So Charles is our first choice. And it's not really that difficult to set up, so we haven't tried anything else. I don't know if that helps you, but yeah.